Hey everyone, Dave here. In this video, I want to start building out a NEP-5 token in C#. So if you don't know what a NEP-5 token is, it is a smart contract on the Neo blockchain that has a standard set of methods on it that allow you to create your own token. And because we have this standard set of methods that all these wallets, exchanges, APIs can consume any smart contract that it adheres to the standard. So pretty straightforward. The contract implements just a few methods here. So you can see here on the GitHub project for the proposals under NEP-5, there's a total supply that will return the total supply of the tokens in the system, the name of the token, the symbol of the token, how many decimal places the token has, balance of, and this one takes a parameter here, of the account to get a balance of someone's account, and a transfer method to move the token from one account to another account here. There's some optional ones as well for allowance, transfer from, and approve. This allows you to authorize other people or systems to move funds, and they are optional, as well as an event that'll fire when a transfer occurs. That's it. So let's get started. Now, there's going to be a few things that you should have installed on your system and have set up already. And there's lots of documentation on doing these things. So I'm not going to cover that in this video here. So the first thing you'll want is to have the Neo plugin installed into Visual Studio. You're going to want to have the Neon compiler. I think it'll be called the Neo compiler on the GitHub site, on the Neo GitHub site. But actually the exe is named Neon, so you'll hear that term maybe interchangeably. So that has to be downloaded and installed and ready to go. I would also recommend you get a private chain running. So the City of Zion has a Docker image that you can get that I prefer. It's got some gas, like it's ran for a while, so there's already some gas built up on it. So you can start off and test with lots of gas. You don't want to run this on the test net to start with because you're going to burn through all your gas very quickly. We'll do so many deployments, it'll be not even funny. And the other thing that's optional, but I'm going to use in this video, is a tool called the Neo GUI Developer. So it's a fork of the Neo GUI that has a few nice things for developers in it that we can get a little bit of info and work with things a little bit easier. So, okay, that being said, let us create a new project here. So I'm going to call this tutorial token. Why is my shift key not working? There we go. Tutorial token, and it's a Neo contract. And I'll just do a build here to get the NuGet packages down. I'm going to start off by renaming this here. So tutorial token. Yes, I'm using ReSharper for this. The name of this does not matter. When it compiles, it doesn't matter what the name of this is at all. It's just I just don't like seeing contract 1. I'm also going to delete this first demo line in here. And what we're going to do is add some parameters to this main method. So if you've never worked with smart contracts in Neo before, the main method is always the entry point to the contract. So if we had another method in here called blah, there's no way to enter into just this here. It's always going to call this main function here. So maybe I'll make that a little bit clearer. If action equals ta-da, call blah. So based on this action is what we're going to do. So this is a bit of a silly example, so I will delete it. The other thing we're going to take in here is a params array of object. Sorry, I don't want to call it that. I want to call it args. So we're going to pass in an action, which is basically what to do, and then an array of arguments that can range from 0 to many arguments passed in. Now we have to implement our NEP-5 methods here. So total supply, and I'm just going to return to do for now. You'll see it's going to give me some issues here because we actually return void here. I'm going to change this to an object. And I'm going to copy this a few times here to implement our different methods. So we've got name, symbol, decimals, balance of, and transfer. Now you'll want to note that these are case sensitive here. So you do want to ensure that you match the case of the NEP-5 standard. Otherwise, things are not going to work as you expect. It's complaining because not all code paths return a value. So I'm going to return false. And there we go. We have a NEP-5 outline built here. So the first thing I'm going to do is I want to put a name in here. So I'm going to call this tutorial token. And I'm going to have the symbol here of be tutorial token, TT, sure, why not? And then the number of decimal places here. Okay, so that's what I want to start with here. I just built it. And I like to check the output window now and then to make sure that it actually did do what it said it was going to do. So what actually happened was Visual Studio compiled this into a DLL, and then the Neon compiler picked up that DLL and inspected it. Let me explain that a little bit better here. It compiled the DLL, and the DLL is, if you've worked with .NET, you know that it's MSIL, Microsoft Intermediate Language. So it's a set of instructions in there that is not architecture specific. So it doesn't matter what kind of CPU you're running on. Now what the Neon compiler is going to do is going to inspect those operations and convert those into operations that are compatible with the Neo VM. Now the Neo VM is what's going to run inside of the consensus nodes and inside of the Neo GUI as well when we locally invoke things and test things. So we actually can run this in multiple different places here. So you will see here that it converted everything and it wrote out an AVM file. So the AVM file is all those operations in a Neo compatible format. So I'm going to fire up the Neo GUI developer here. And I'm going to open my wallet. You can see here I've got lots of gas for testing here. And I'm going to deploy this contract. So one of the reasons I'm running Neo GUI developer from source is so that I can muck with things here. And you see that I've already gone and I've mucked with this screen here and hard-coded in these values. This is because you have to type all these values in when you go to deploy. And I just got sick of typing them in. So one thing I do want to cover though is this dialog here. So it's a little screwed up here that it actually should be parameter list and then return type here, but this label is somehow bumped up there. The parameter list is actually 0710, and that corresponds to our contract, which takes in a string and an array. And then the return type is 05. So if we bring up the parameter document here, you can see here that string is 07, array is 10, and then the return type is 5. So we're returning a byte array out of this. There's no return type of object in here. So this is a good reference to have, but for a NEP-5 token, it's always going to be 0710 and return 05. I also need storage checked off here. We're not going to use storage quite yet, but we will need it, so I just hard-coded it to be on there. So you'll notice this little load button. This allows us to browse and find our AVM file. And then you'll see it'll put the actual hex encoded data in here. And then you'll see this little guy here. This is the script hash of our code. So it's taken our code and run a hash algorithm on it, and this is what we get here. This is very important to copy right now, because this is what we're going to use to communicate with our contract. So if I click deploy, it tells me what the script hash is. We just copied that from the previous window. At this point now, it hasn't actually deployed it. It's actually copied this information, basically the code, over to the invoke contract window so we can test it. What testing it will do is run it in our local VM. So it doesn't run this on the blockchain, runs it locally to figure out whether this will succeed or not. So we get a VM state of halt, break, which does sound kind of negative and bad, but that does actually mean it finished. If there was an error, it would have a fault in there. The gas consumed was 500. And then you'll see here the fee is 490 gas. So the reason that there's a difference here between 500 and 490 is because your first 10 gas is free. So let us now go and invoke this. It has sent it. We get a transaction ID back. And now we're going to have to wait for a block here. So it's at 14 right now, but I can start to get our window ready here. I'm going to paste this script hash in here. Oh, perfect timing. And it did a search. It found that. So it came back as tutorial coin. These are all the metadata that we put in on the previous screen. And here we can type in name. And we can test that here. And you'll see that it finished, consumed a little bit of gas. And then there was a value that came back here. Now I remember how we return an object, which is actually a byte array here. So this is a hex encoded version. So this is a site I use just for handy hex decoding. And you'll see here that it decoded to tutorial token. We can also type in symbol and test that, which came back with T and then T again. And the other method we implemented was decimals. So and it came back with a value of 2. So the interesting thing here is that it did realize that it was an integer and returned us back just the integer. This seems to work on small numbers. When you get to larger numbers, it returns it as a hex encoded byte array as well. Now you'll notice here that I just did a test. I never clicked this invoke button. The reason I did that is because the information we're consuming of the name, symbol, decimals is information that doesn't change. And by invoking the method wouldn't actually cause a chain on the blockchain here. So test is actually taking the information that we've downloaded, our local copy of the blockchain, and searching for that data and displaying it to us on the screen. So there's no reason to actually run this on the blockchain. The only times you want to do an invoke is when the state of information is going to change. So if a method we're calling were to, transfer this token between parties, or to change the amount of supply, or to do those kind of things. But in this case, we're not doing that. So I want to also show you now a few little gotchas here. So for total supply, let's say we want to have 1,000 of these. You would think you would just return 1,000. The problem with that is that the NEP-5 and I believe the underlying NEO system is working on whole numbers. So we actually have to have, if we wanted to have 1,000.00, because we have 2 decimal places, we would write it as that. So here we need to return 1,000.00. And I personally like to put a continuation character in there just to keep them separate and be able to read it. if you have maybe a large token, you may want to put 2 underscores or 3 underscores to signify the decimal place. For us, 1,000 is readable, 0.00. That works for me. Okay, we've built that. Now we need to deploy this contract again. So I'm going to load it up. And I'm going to take this script hash again. You'll notice that it's changed because the code has changed. Therefore, the hash has changed. And we'll go through our invoke procedure here again. So now we got to wait for the next block here. So 27, there's 28, perfect. And I want to call total supply. And we test this here. You'll notice that it comes back as a byte array with a value of this, which is hex encoded. And this is where things get a little tricky that I've noticed here, is how to properly decode this. Well, it's obviously not ASCII. You'll see here under the uint32 little endian that it's 100,000. But if you look at a big endian, that is a different number indeed. And if you haven't worked with endianness before, it is how information is stored internally on these different architectures. So in some systems, the most significant digit will be at the end, right? So if we had 1,000, it would be basically stored as 0001. Whereas on the opposite, on some architectures, would be stored as 1000. And if you know the endianness, you just have to convert it. And you can actually see here, if you look at the raw, is that they're just reversed arrays here between the big and little endian, right? And that's all there is to that. This is why I like using this site, is because it'll actually do these decodings into different formats, so it can help kind of deal with some of those issues of decoding that information. Now, you may be looking at this and saying, well, if I were to write this, I would do this using a switch statement. So I'd have a switch for the action and then cases for all of these. This will probably end in disaster, funny enough. And this is what I did when I started out building these tokens. The reason for that is that when you write a switch statement, it will work in certain cases. So if you have a small number of branches in it, so only a few case statements in it, when it compiles to the intermediate language, the instructions will look like an if statement. And the Neon compiler will pick that up just fine. When you exceed that threshold, and I cannot remember what the threshold is, it will compile to a different IL code. And the Neon compiler will not interpret it properly. I can't remember if it actually causes the Neon compiler to exit and fail with some error message, or if you just get bizarre results in your code. It's been a while since I've done it. I just know to avoid it. So it's really important to note when building these tokens that there's certain things that you can write in C#. Actually, there's a lot of things you can write in C# that when the Neon compiler gets to it, it just will not like, because it doesn't have an operation code internally to support it. So the Neo VM is really limited in what operations it can do. So yeah, it will get you. A great demo of this is, you know how I was saying that this is case sensitive here. So if I were to go action equals action dot to lower, just to lowercase everything before I do my matching in here. Now I know some of these will fail because of uppercase letters, but if I build this, we get a build failure. And if we look at our output window, it's a little easier to read here. You will see that the Neon compiler said string.toLower unknown call. So it really does not know what to do with something like toLower. And you're going to run into lots of operations like this with when you start working with Neo, it's going to be maybe a little bit frustrating. If you come from a strong C# background, there's certain things you'll want to do, and the Neon compiler will just not like it. Or even worse, it won't do a complaint, and then when you actually try and run your code, you'll find issues with it. Those are the harder ones and the more frustrating ones. I think that is all I'm going to cover now. In the next video, we'll deal with how to deploy this contract, basically to initialize it, to set it up to give the tokens to someone, and doing the balance of method. So I hope you enjoyed watching. I always look forward to feedback, and we'll see you in the next video.